Well, I finally broke down and bought myself a new air conditioner. This is a Kenmore 8000 BTU portable. This unit was actually manufactured by a Chinese company, Gree, G-R-E-E, and they manufacture the Soleus air conditioners under their own private label. But a lot of their stuff is sent out to other distributors and sold under other names. But this is a pretty well-equipped model. It's a single hose unit, and I'll talk a little bit about the difference between a single hose and a double. I bought a portable air conditioner because I can't fit a conventional window AC in my Anderson crank-out casement windows. It's just not really possible. Well, it is possible, but it requires constructing a special mount. And as a result of doing such a thing, you can never close the window, which, I don't know if you guys get what I'm saying, but the window opens out like this, and it's on a crank arm. And the way it's designed, if the window is open enough to fit a conventional air conditioner, it actually sticks beyond the roof line, which extends down this way. And the rainwater runs off onto the air conditioner and splashes back towards the house and can leak around the air conditioner mount. So in a situation like this, building a panel with an opening for the air conditioner duct is the best solution. And that's what I've done over here. Now, this is only temporary. I built one out of coroplast, which is corrugated plastic. And I cut a section out to fit the ventilation duct. But I have the window open about maybe 5 or 6 inches, just enough to allow the air to escape. So a dual hose model has an intake and an exhaust. And it kind of has two circuits. It has the intake from the room, which exhausts out through the evaporator side. And the other circuit draws in air from the outside, which cools off the condenser, and then sends that superheated air out the other hose. This way, you never have a situation where the pressure in the room is negative or positive. It remains neutral. But given my situation, I needed a compact unit, and I didn't want to rig up 2 hoses, although it wouldn't take much to do so. So this is what I came up with. See, what would happen if I had a dual hose model? The only way I could get it to work effectively is if I had the intake on the bottom and the output on the top. So I would have hoses coming out my window that way. And I say that because if I put them side by side, they would be too close together, and the window panel or pane would have to be open all the way all the time to run the unit. If the window was closed part way to prevent water from entering the house, then the air would bounce off the window and get sucked right back in. And this way the evaporator or the condenser would never cool off properly. One benefit of the single hose model is that it actually utilizes the air from within the room, which has been cooled, to actually facilitate cooling off the condenser. This actually wastes a little bit of that cooled air, but it helps the unit run a little more efficiently. They both have trade-offs. Ultimately, the best way to go would be to have a dual hose model, but in my situation, of course, as I explained, isn't really an option. So we're going to take a look at the unit before we fire it up. I'm going to pop the the exhaust hose off. I'm going to wheel it out and you can see what it looks like inside and outside. So as you can see, it's about as compact as they come. 8,000 BTU is about as small as you can get for a portable unit. I couldn't find anything smaller, nor would I want to. An 8,000 BTU unit is good enough for about 350 square feet tops. This room is about that. Actually, no, this is more like 200 square feet, I think. No, let's see. And then you have to figure in the high ceilings. Realistically, I should have about a 10,000 plus. But unfortunately, when I bought my unit, the only thing they had in stock was this. They didn't have any of the 10,000 BTU models left. They had bigger ones, but they were too big for me and too costly. This was kind of a last-minute purchase during a heat wave. I was lucky to get what I found. So, like any conventional home air conditioner, you do have filters, and they're located here. And they are washable and reusable. The evaporator kind of has an L shape to it. It goes from here around to here, and there are two blowers, one on the top, one on the bottom, that run off the same motor. And the condenser side has an intake here and here, and the output is here. It actually takes the air from the compressor area as well, so it kind of cools off the whole unit. This is the drain hose. This is what you call an evaporative condensate evacuation system. I made that up. It sounded good, didn't it? No. What it does is it actually collects all the condensate at the base of the unit, and as the air comes through these vents, through the condenser, it's heated. And then it actually it pulls the air in an evaporative manner through the exhaust and out the window. This way you don't have to rig up a drain inside your house or drain it outside. It just does it on its own. In the event that the humidity is ridiculously high, like during a rainstorm, for example, and the water is collected at a rate faster than it can evaporate, it actually shuts the compressor off. There's a float inside there, and when it gets too high, it shuts the compressor down and keeps the motor running so that the air is still flowing through. Once the water comes down to a safe level, the compressor should kick right back on again, and it'll continue cooling. But that's to protect you and the unit. See how this goes in. There we go. Oh, let's try that. Shh, I don't like that sound. Does it go? No. Let's try this again. There we go. Perfect. Anyway, on the back we have a cord storage location. The drain. This is a plug for the drain when you're not using it. You can take this off. Actually, this is how it ships. But if you want to drain the unit manually, you just take this hose, take the cap off, and tilt it down, and it'll empty out on its own. It's on wheels, so it's easy to move around. It doesn't weigh a lot. This is the evaporator blower. And as I mentioned before, there's a motor in the middle, and the other squirrel cage blower is down here. Couldn't be simpler. I mean, really, when you look at what's inside an air conditioner, it's amazingly simple. You would think it'd be, all kinds of complicated, but it's not. We've got a compressor, an evaporator, a condenser, a receiver dryer, a couple of sensors, and of course, being a modern electronically controlled unit, it has a control board, which helps facilitate its many functions. changes the motor speed. It has multiple motor speeds. So let's turn this sucker on. Oh, whoops. I turned it off with the control panel up here, and I had it turned on with the remote, so they were not in sync. Anyway, so this is the basic fan mode, and you control the fan speed with the remote. High, auto. This is high. This is low. You hear the relay clicking whenever I change the speed. It also has a dehumidifier function, so it can be used strictly to dehumidify the room. And this little bucket light just means that the water bucket is full, so that it'll continue running until it empties itself out. We'll put it on air conditioner mode. So just watch the indicator on the remote. Cool. There goes the compressor. And of course, if I hit dry, it'll go into dehumidifier mode, which really isn't much different from air conditioning mode. You just can't control the temperature. It shuts itself down when the humidity level is at a preset amount. So right now we're on low cool, 73 degrees, and currently the room is it's 80 degrees in here. So in a little while we'll see a difference. And I'm going to bring the fan speed up a little bit to its maximum. There we go. The remote also has a sleep function and timer mode, and it also can be locked, so a child can't grab the remote and start playing with the unit. You actually hold down one of these buttons or something and it goes into lock mode. But pretty handy little unit. I mean, it does work. It brings the temperature on average, I'd say, between 5 and 10 degrees below ambient temperature. So that's not too bad, given it's not in an ideal situation. Because of the way my house is designed, it's well insulated. This place is insulated about as well as a vault. The problem is, it's an open concept, and the cold air, which sinks to the floor, naturally gravitates down the stairs, and it never reaches, I shouldn't say never, but it rarely reaches the set point. So it runs a lot. That's pretty much how it is. So